Hello, I'm Alberto Viotta, process engineer in the Ferriere steel plant. In addition to this facility, the Pittini Group has two other facilities, one in Verona and one in Potenza. Now let's go in the front of EAF furnace, the heart of the entire steel mill process, where we will see the scrap behind me being melted into liquid steel. Here we are in the main pulpit of the melt shop, the EAF electric arc furnace pulpit. This is where the whole melting process is managed and monitored automatically. The automation ensures total operator safety when carrying out operations and the best control of the entire production cycle. The EAF consists of a vessel with refractory lined bottom shell that contains the liquid steel and a section of water-cooled panels that contain the scrap to be melted. The scrap comes from the recovery of the steel. After charging, the roof is positioned over the furnace and the melting process starts. An electric arc ignites between the tips of the graphite electrodes and the scrap starts to melt. The arc is sustained thanks to the electricity that we purchase and which derives mostly from renewable resources. To reduce the consumption of electricity and provide extra chemical energy to the scrap, the melting furnace is equipped with oxygen, natural gas, burners, and supersonic oxygen injection lances. These devices also permit to reduce the tap-to-tap time of the furnace. Extra chemical energy is provided by wall-mounted oxygen fuel burners and oxygen lances that combust and then cut the scrap. Both processes accelerate scrap meltdown, and supersonic nozzles enable oxygen jets to penetrate forming slag and reach the liquid bath. An important part of steel making is the formation of the slag, which is a mixture of oxides with a lower density than the liquid steel. The slag that forms floats on the surface of the liquid steel, and before tapping the steel into the ladle at a temperature of 1620 Celsius degrees, pours out from the slag door. The slag overflows into a tunnel located under the furnace, ready to be conveyed to another plant for further processing. Slag from an EAF would normally be a potential waste, but we recover it and turn it into a new product called granella. All these complex operations are managed and controlled in the various supervision systems installed in the workstations of the EAF pulpit, the thinking brain of the entire process. The high degree of automations make it possible to achieve the maximum performances, a reference for our competitors. The furnace can tap automatically and the operators are constantly supported by the automation system through the entire melting phases. The online supervision and control systems make it possible to constantly monitor the melting process and to store data for the continuous improvement of performance. After tapping in the ladle, the steel is transferred to the lathe for further treatment. At this stage, the lathe is used to maintain the temperature of the liquid steel while it's analyzed and modified by the addition of ferroalloys. The deep desulfurization process that is implemented in the lathe is necessary to achieve the quality requirements of the heats. Once the chemical composition required by the production datasheet has been reached, the ladle passes through the continuous casting machine. Here, the steel passes from the ladle to the tundish that splits the steel in the strands. Each strand consists in a water-cooled copper mold where we create the first solidification skin of the billet, and then the billet passes to the secondary cooling, where sprays finish to cool it. After the exiting the cooling chambers, the formed billet is automatically cut by the torches and then sent to the rolling mills or stacked in the billet warehouse. The billets are transferred or stacked by traveling cranes. You can now follow the billet to the rolling mill by selecting which rolling mill, wire rod or rebar.